This is our first application of the Universal Robots UR10 Collaborative Robot, or Cobot. The basic task previously performed by a full-time person requires nesting the two parts and separating the long and short into separate cartons. The first step was fairly simple and involved consistently flipping one of each of the parts over. Due to the cycle time, this task was offloaded to the press robot. We also positioned the grinder so the press robot can drop the runner to grind and reuse immediately. After several long hours of testing, we found a simple way to align the parts that greatly improved the ability to create neat pallet stacks. The approach position also is critical to mating the parts face to face without overlap. We incorporated a sensor at the head of the conveyor to allow the conveyor to run every 2 shots and a sensor at the end of the conveyor to stop it. The speed of the robot had to be optimized to keep ahead of the molding machine cycle without going too fast, causing it to shift around or endanger co-workers. After the robot completes one set of cartons on the left table, it starts stacking parts on the right table while the operator is clear to slide a box over the parts and flip it over. We used variables in the Cobot program to indicate the pallet set, left or right, and part up and down position. If then else statements and loops were used in the programming. Subprograms were not used in this application. We ran a continuous simultaneous thread program to monitor the sensors and move the belt. There are 8 pallet stacking positions with up position and down position overlapping. The parts cooling on the conveyor and stacks on the table allow for easy inspection, and the Cobot keeps the short and long parts 100% separated. Our next application, which we developed first, involves unpacking substrate parts to be placed in the press for overmolding by the press robot. It connects to a conveyor and interacts with the other robot to safely enter each other's space without collision. That application will free up a part-time operator from placing 2 parts every 2 minutes to placing 2 cartons every 20 minutes. Through this process, we have learned and assessed the risk involved with collaborative robots, including collision, caught between, crushing, and electrical hazards. The collaborative robots are very safe, but workers do need to stay clear of the movements. At higher speeds, safety barriers and/or sensors may be needed. It is also important to be cautious of the robot starting movement unexpectedly, especially if triggered by sensors that may be within operator reach.